Hey guys, welcome to IoT, that is Understanding IoT. In this section, we'll break down what IoT is, how it works, and the amazing ways it's already shaping our world. IoT, or the Internet of Things as it stands for, is all about connecting physical devices to the internet so they can share data, work together, and perform tasks autonomously. It enables everyday objects like your thermostat, refrigerator, or even your car to communicate with each other and with you. So for example, imagine your coffee maker starting to brew coffee as soon as your alarm goes off. Or imagine your thermostat adjusting temperature based on your schedule, which is very common. Or your car even sending notifications, maintenance alerts to your phone so you can know when to maintain your car. That's IoT in action. It's the idea of turning everyday objects into smart connected devices that not only save us time, but also improve efficiency, enhance convenience, and even reduce costs. In industries, IoT is revolutionizing manufacturing, healthcare, agriculture, and logistics by enabling real-time monitoring, predictive maintenance, and automation. The potential is incredibly vast as IoT continues to integrate more devices into a seamlessly connected world. IoT already is everywhere in our daily lives. So if it's your first time hearing of IoT, you're going to soon realize that it permeates our society. Let's just give a few examples of IoT products. Smart homes. You can control lights, thermostats nowadays, and even lock your doors remotely through your phone, which is incredibly useful and powerful. So many times we've forgotten to turn off the thermostat or lock our doors when we leave our house, and just being able to do it with the push of a button from our phone is incredibly powerful. Next, wearables, like fitness trackers such as the Apple Watch or Fitbit, which can monitor your health metrics and give you critical insight to your health so you can improve your health. There's a huge industry around wearable IoT products. Also in industries, IoT optimizes factory equipment and enhances safety. These small examples show how IoT is pervasive in our society, and it's improving convenience, efficiency, and even productivity. So to understand how IoT works a little better, let's talk about 4 key components of regular IoT systems or common IoT systems. First, sensors. Devices like motion detectors, temperature gauges, cameras that collect real-time data from our surroundings. They act as eyes and ears of the system, capturing valuable information. Next, actuators. These perform actions based on the data received, such as unlocking a door, turning on a fan, or adjusting the brightness of a light. They serve as the hands of the system, executing tasks. Next, communication protocols. These include technologies like Wi-Fi, Bluetooth, Ethernet, or cellular networks, which allow sensors and actuators to process and exchange data efficiently. Think of them as the nervous system, enabling seamless communication between devices. Finally, a processing unit, which is probably the most powerful or important thing, a microcontroller, microprocessor, or even a cloud-based server that analyzes the data, makes decisions, and triggers appropriate actions based on the data and the code you design. It's the brain of the operation, ensuring everything works as expected and functions together efficiently and properly. Now here's a simple way to understand how IoT works. A sensor detects something, like motion or temperature. The data is sent to a processing unit, such as a microcontroller, maybe Arduino or Raspberry Pi, whatever you prefer, through a communication protocol, maybe Wi-Fi or another type of communication protocol. The processing unit then analyzes the data and triggers an actuator to perform an action, like turning on a light, let's say. This flow, sensor to processing unit to actuator, is the basis of several IoT systems. In more complex setups, you can have combinations of multiple sensors, multiple processing units, and actuators working together to create a network of smart interactions for more advanced functionality. So before we wrap up, let's look at where IoT is headed in the coming years. With 5G, devices are becoming faster and more efficient, allowing information to be highly available. With the hopes of 6G in the future, this is only going to get better and better. AI, as many of us have heard, incredibly popular buzzword these days, is being integrated into IoT to make devices smarter, like voice assistants, which are already pretty popular, that can learn from your behavior. IoT is also revolutionizing cities by optimizing traffic flow with smart signals, reducing energy consumption through intelligent street lighting and building systems, enhancing public services with real-time monitoring and data-driven decision-making. These trends are shaping the future of IoT. Introduction to Arduino. Now in this section, we'll talk about Arduino as you see here, which is what we'll be using today to build our project. We'll talk about why it's ideal for IoT, and we'll start by setting up our first project, a blinking LED. Very exciting. We'll get a little hands-on so you can get warmed up for later on when we build our real project. So what is Arduino? Well, Arduino is an open source electronics platform that combines both hardware and software to make building interactive projects simple even for beginners. Being open source means that its designs for hardware and software are free for anyone in the world to view, modify, and share. This fosters innovation as the global community can contribute to its development, create new features, and build custom versions to suit specific needs. The hardware includes boards like the Arduino Nano, which is what we'll be using in today's course, and several other boards as well, such as the Arduino Uno, which may be their most popular board, and you may have heard of it if you worked with Arduino before. The Arduino itself, or the software itself, is called the Arduino IDE. It makes it very easy to program these boards. You can use libraries, download examples, and it's very beginner friendly to use, and it's free to download. This Arduino environment, or the Arduino framework, was actually introduced back in 2005, so pretty old, and it was introduced by a guy called Massimo Bonzi and his team to create a low-cost, user-friendly way for students and hobbyists to learn about electronics. Now the name Arduino comes from the bar they used to meet at. So they used to meet at a bar called the Bar di Re Arduino in Italy. I probably butchered that, but you see the bar has the name Arduino in it. And this is where the founders used to talk about the Arduino platform, brainstorm, and they're so inspired by the concepts and the spirit at this bar when they were discussing Arduino that they eventually named the platform as part of the name of the bar, which is pretty cool. But that being said, today, after almost 20 years, Arduino is still one of the most widely used frameworks for IoT projects because it's very versatile, cost-effective, open source, and has a massive community of supporters from beginners and experts alike. Whether you're controlling LEDs, motors, or sensors, or building a very serious IoT project for production, Arduino can work for you, and Arduino makes many things possible. So really, why is Arduino perfect for IoT? Well, Arduino's popularity stems from a few key factors, and let's talk about them a little more. First of all, it was really innovative for the time because back 20 years ago when the founders in Italy were discussing this, there was no general framework for creating such projects, combining hardware and software for boards. It was, at that time, pretty tedious to make such projects, and hence that's why they met in Italy at the Arduino bar to discuss ways to make building projects in electronics easier for beginners, and eventually they came up with this innovative idea, and that is Arduino. Next, it's incredibly affordable and accessible, as you may know, so this makes it nice for beginners and college students who really can't afford expensive parts. Many boards and modules and sensors are under $20. The Nano board we're using today and all the sensors we're using today are actually under $20 US. There are even more powerful boards that aren't that expensive either, such as the Arduino Uno. It supports countless sensors, so these boards support being able to connect countless sensors and modules. The possibilities are endless. All Arduino boards make it seamless to connect modules, actuators, sensors of all flavors. There's a lot of complexity taken out when you prototype thanks to Arduino boards because you just have to connect these sensors and the magic happens in most cases. Plus, the community is really large, as we mentioned, so if you do have an issue with the sensor, you never used the sensor before or a module, there's a 99.9% chance you could just Google it and someone can show you how to do it on a YouTube video or a forum, or if you're having issues with components, there is also a very high chance someone has had the same issue, documented it, and has shown the solution. Okay, so let's talk about the components we need to actually build our first program, that is the BlinkLED program. First things first, we need an Arduino Nano, as you could see here. This is the Arduino Nano I am using today. It comes with pre-soldered headers. So pre-soldered header means it comes that these pins here, as you could see here, pins here and pins in the back there. So let me focus this. That was unfocused for a second. So these pins in the front and these pins right here as well, and there's some pins that we won't use that are also right here, these come pre-soldered. So oftentimes when you buy these modules, what will happen is that these aren't even attached to the board. You have to do a process called soldering, which you may have never even heard of if you're watching this tutorial, where you take a hot piece of metal and you pretty much connect the pin to the board, and this is what allows you to connect your components. This is really important because without this, it'll pretty much be impossible or really difficult to connect any sensors, Bluetooth modules, and we'll need those things later on when we build our actual DIY musical gift box. So we are using a pre-soldered Arduino Nano for today. On top of that, Arduino Nano uses USB-C, as you see there. So I already have my USB cable attached in there. Other side goes to my computer. The one I showed you earlier uses a different form of USB, an older form of USB. But as we talked about, the newer versions of Arduino Nano use USB-C. Okay, so that's our Arduino Nano. That is the brain of the operation for the BlinkLED. Now that we have our Arduino Nano, we could just take our LED. So we also need an LED. So this is just a red LED, pretty standard, comes regularly with most Arduino starter kits. And of course, you don't have to use red, but it's probably the most common color for this project. And next, on top of the LED, we need a 220 ohm resistor, as you could see there. So this 220 ohm resistor, it's kind of hard to see it because it's so tiny, but this is for ensuring a stable flow of currents to the LED. And that is good practice to prevent the LED from potentially burning out, because they can if the current overflows. Another component we need is a breadboard. So a breadboard is very important. We'll be using it for the BlinkLED, and we'll be using it in our final project, the DIY musical gift box. This breadboard allows you to organize components nicely, and it's great for prototyping. There's many rows where you can organize and connect your components, and there's even a power rail here, which we're not going to get too much into. We'll get into it later on with a DIY musical gift box, because we will be using the power rail. But for this BlinkLED, we won't be using it. Pretty much it allows you to distribute a source of power across the board, which makes it easy to power multiple components with the same power source. So the LED, or the breadboard's there. And the last thing we need, probably one of the most important things for these projects, are jumper wires. We're using male-to-male jumper wires, as you see here. Important, you have a jumper wire kit. Always keep a hand of jumper wires with you, not always male to male, but sometimes you just want other female to female or female to male. I would imagine you already have a jumper wire kit. So those are all the hardware components we need to get this LED project running. Let's talk about the Arduino IDE, setting that up and writing our code and connecting the components as well after that, and finally putting it all together to see the LED blinking. Okay, so now that we have our hardware, let's go ahead and download the software, and that is the Arduino IDE. If it's your first time, it's really simple to download the Arduino IDE. It'll be really quick. Just go to arduino.cc, go to the software section, and then just go down to the nightly builds and select whatever your operating system is. I'm on Mac. I already have this downloaded, so I'm not going to go ahead and click download, but you can go ahead and do that and walk through the download process. It's pretty straightforward. You can also contribute and download if you like, and once you have that, you will have the Arduino IDE installed on your computer. Okay, so now that we downloaded the Arduino IDE, let's quickly revisit our hardware components and talk about the connections we need to actually write code in the Arduino IDE to get this circuit to work. So you see, I already have my components assembled, and you can go ahead and assemble just as I did here. So I went off screen and just connected them. Very simple circuit. So let's briefly talk about what is going on in this connection. You see I inserted the Arduino Nano here. And sometimes it is a little tight when you insert these components, so feel free to put a little force to insert these. Do not shy away from doing that, because these new breadboards are a little tight, especially if you haven't used it before. So go ahead and push that in. And the first connection we have is D13, so this is a digital output pin. This is the first pin there on 1, and this is green. Now the connection of the jumper wire does not matter, just it's good to use different color connections for organization purposes, but this D13 is connected to row 20. And what this wire is doing is it's going to send a signal to the LED, and it's going to be able to turn it on and off. So this is what's providing power to the LED from this D13 pin. And also on this row 20, we have the resistor. So both ends of the resistor, you can see I bent there, and they're on row 20. And this resistor is just to prevent a large amount of current from reaching the LED, because if we do get a sudden spike in the current, it could potentially burn out the LED. Now both ends I bent and are inserted on row 20. The next connection I have here on this board is the LED. So the LED is actually, both ends are on separate rows, so we want to talk about that briefly here. If you've looked at these LEDs in detail, you'll see that one end is longer, one end is shorter. The longer end is for receiving power, and the shorter end is for the ground side. So the longer end in this case will receive power from the digital output on D13, so that is on row 20, and the shorter end will insert into another row, so we'll do row 21. So they designed them like that for a reason, just so you could distinguish the flow of currents. So let's go ahead and insert that back in. And once we have that, we just connect another jumper wire to the shorter end, and that is connected to the ground pin on the Arduino Nano, as you see there. You can use any ground pin. There are several. I just chose this one because it's the closest. And that's pretty much all we need in terms of the connection. So make sure you have this connected now to the USB-C, and now we can connect the other end into our computer. Okay, so now we have everything we need to write our script for the BlinkLED. Go ahead and open the Arduino IDE and go ahead and go to New Sketch. So New Sketch is going to be the environment where we're going to write code that will eventually upload to our Arduino Nano. So go ahead and click New Sketch on the top left there. And it should take you to another screen where we're going to write our new code. And yours shouldn't say Arduino Nano here yet. Mine only does because I connected everything. So to get the Arduino Nano to show up here, first things first, you want to go to the boards manager on the left. So that's this little board, and go ahead and search Arduino AVR board. So I already have Arduino AVR boards installed, but you can go ahead and search it in the search bar, find Arduino AVR boards, and go ahead and install Arduino AVR boards. Now, this boards manager is important because in the future, you'll be using it later on if you are using other boards, because some boards are not supported inherently or from the base version of Arduino IDE, you have to download their boards manager. So in the future, if you do get more advanced, there's going to be a bunch of things you'll install here, because this is very important and it'll allow you to connect to other boards. So keep that in mind. We're just going to download the Arduino AVR boards for now. And once we have the Arduino AVR boards installed, we can just go to the tools on the top and we can go ahead and select our board. So go here and let's just go to Arduino AVR boards and select Arduino Nano. So once we have that selected, next we want to select the port. So if your USB is connected to your computer properly, you should see a port, something like this. I'm on a Mac, so the serial port looks a little different, but you can go ahead and see which port is your Arduino Nano by plugging it in and out, and it should pop up. And mine looks to be this port, so I'm gonna go ahead and select this port. Okay. And finally, the last thing we're gonna do, we're not gonna talk too much about it, but we have to select the old bootloader for this chip. So we're going to select @Mega328P old bootloader, and we can go ahead and select that. So we have all the setup here to write our code. And so we can go ahead and delete the skeleton code they gave us and just paste in this new code. And this will be provided for you. Actually, we don't want to save that yet. It doesn't really matter. But so we have this sketch, and this is the code we'll be using to blink the LED. So let's briefly talk about this code if it's your first time seeing code at all. So in this code, so it's a C++ based, as we mentioned. And in this line 2, what's happening is we are just setting this constant integer as LED pin. It's going to be 13. So the reason it's 13 is because the digital pin we're using is 13. So Arduino IDE is smart enough to tell that it's going to use 13, so we'll assign 13, and it knows that's a digital output pin. So that's pretty cool. So we just assign something called a constant integer as LED pin 13. Now that we define the LED pin, we can go into this void setup function. So this setup is something that runs once as soon as the code starts, so only runs one time. So keep that in mind. So what we're doing in this setup is we're telling Arduino, based on this function they provided to us, so we're using the pin mode function, which is provided to us in the Arduino IDE, we're saying that we want this LED pin that we assigned 13 to be a digital output pin. So it's going to output a signal on that D13, and that signal will be high or low. So if it's high, it's going to turn on, so it's going to send a voltage to that LED. If it's low, there will be no voltage and the LED will turn off. So that's all we're doing in the setup, and pretty simple setup there. You'll see this a lot if you're going to continuously work with Arduino IDE, and we will use it later on in the DIY musical gift box example. Next, we have the loop, also incredibly common. So this is pretty much used in every Arduino script. This is something that's running as long as the Arduino is powered on and the code is uploaded. This is going to continuously loop, hence the name loop. So what's happening in this loop is we are just writing to that LED pin. So as we mentioned, we're calling it high. So we're setting it to high. And once we set it to high, that means we're going to induce a voltage on that pin. So it's going to turn the LED a bright red. And then we're going to wait 1,000. So that is 1,000 milliseconds. Do not get that confused. They just do it in milliseconds because a lot of the times you want to be very granular with your time. So the way you do this delay is make sure you have milliseconds in here. So 1,000 would be 1 second. You can go ahead and play with the delay and see how frequently on and off you want the LED. But now we're only going to turn it on for 1 second. After we keep it on for 1 second, we're just going to turn it off. And then, so we just set the low as we discussed. Same function, digital right, but this time low. And finally, we wait 1 second, and then we just repeat the cycle. So now that we have this code understood, we can go ahead and upload it. So if our board's connected, we have our code proper without any modifications, we should be able to do that. So go ahead and just take a second to upload it, and it should be quick because it's a very simple script. Okay, so now that it's uploaded, you should see your LED start to blink. So if you set everything up properly, it is blinking at this point. Congrats, you just wrote your first script. So if you are an absolute beginner in the programming or Arduino world, give yourself a pat on the back because you just combined hardware and software, and you saw how seamless it was to do thanks to the Arduino IDE and the Arduino framework.